Okay, so so here I evaluate the file valid.row using the C++ include directive, which you can use for robust conditional stuff in macros. Okay, and we got this output from it. So okay, I guess Thomas Love, you had the was it your idea to just put them in parallel with each other?
Yeah, you said that we can have some output that can be in different order, but we
right. This
do
is
the same thing.
Yeah, because it's non-deterministic. So, yeah. You know, this order is only approximate. Things can happen in different sequence, so we're not going to get the same output in the same order. Okay, but if we want to test, we want to use this valid.row as a test program, we need to see if the output it produces is supposed to produce is equivalent to the output it does produce. And in order to test to see if they're equivalent, even though the order may be different, the idea is we have different processes and I had to use parentheses, or parentheses don't work. I have to put squiggly brackets to group them because of the precedence of the equal. So I want this in par with, that's interesting. I don't know, whatever. So we put these, so this is, let's say the output, the first time I ran it was 1 + 1, then 2 + 2. And I don't know why. But that should be equal to 2 + 2 in par with 1 + 1. Now I have a question about if I made this 4 and 2, whether I would still be equal. But let's look at this first. Is this correct? Okay, so we got this output the first time in this order. And then when we run a test of it, and we get this order, so we put these all in par with each other. Put a par symbol between all these outputs. Okay, and then you see if they're equal. What is that?
Yeah, this is interesting.
I did this before and it worked. I don't understand it. I mean, it printed out the right thing. Now, I don't know if I broke. Okay, so I had a slightly simpler case here. I didn't do the plus.
Yeah. Yeah.
So I think this is what I did. Nope, I'm not getting the same result. I'm getting a really weird.
Okay, so something is different.
Something is different.
Yeah. Yeah.
And one thing that's different is I keep losing my history. It keeps wiping out our node.log. Because I have no history here. Very bizarre. File truncated, file truncated. But we can see clearly, I mean, you can see the evidence that when I ran this yesterday, the result was true for this evaluation.
Yeah. But what is?
And now it's bizarre. I wonder what it is. So these things starting with an integer didn't print out, looks like. Well,
I'm not sure if
with the new R node, we can tell much better what the output, the standard output is.
What do you mean, Jim?
Well, okay, robot doesn't recognize these things as being output to standard out in the log.
Oh, I see.
Okay, because they start with an integer, and in the pattern that we look for, we're not looking for lines that start with an integer. Output to standard out.
Yeah, I'm getting the same
unless
output.
The whole thing is an integer, right? If it's just an integer, we'll print it like. And I don't know why we're having this problem with the log. What you can see here is just an integer printed it. You look in the log here. You can see it didn't print out any of these lines. But it printed out this line, which was just an integer. Here, it only printed the first line. It didn't print these two lines.
I see.
So that's a bug. I guess I could.
But this still doesn't answer why.
No, it doesn't
work.
So and I actually have to fix this now because I don't know why I'm not seeing it now, but standard out is giving debug output for that now. Insert. So we want lines that start with an integer 0 through 9. We want to print those out. Okay, well, I shouldn't take all of our time to fix these little things.
Jim, but You didn't use eval. You have this print command, right?
Oh, print.
Right? And print uses standard output because if I use standard output, then I get the result true false. I will now repeat your example.
Oh, okay. I think he's got it. By golly, I think he's got it. Did I do this one?
Now I'm testing this one. Yeah, your first example is correct. For me, it is working.
Okay, so we got the true. So what about?
And explain to me again why eval didn't work, but print does.
In the background, print uses standard output to print this process. Like this whole construction, new and then print output.
Yeah, so the two things were equal. So what? I never printed that out.
Gotcha.
Oh, okay.
Okay, so what I wanted to do is see what happens if I make this 2. Are they still equivalent? They are.
Oh, that's our new member who wants to join in the channel. I'm going to chat with them.
So, oops. So if I put,
this is not valid, right?
What happened? How come oh. Where did that syntax error come from?
This is me.
Where are you?
I'm trying to print with the code.
But I don't see your idle.
Like this, or I will delete this error. Oh, I cannot. Why not? Jim, how should I use eval?
Well, that's what you did. I mean, what you just.
Oh yeah, it's executed. Okay, it's fine.
Okay, so you got output here. It's like I don't. Okay, so this is in par with that. I'm not exactly sure.
And Gary, my example is exactly the print command.
Okay, got you.
It wraps just output and prints this output.
Okay, thanks. That makes sense.
Oh. I guess that won't hurt the results of using this as to test to see if things still work. We're not going to have the case where it's going to have 1 + 1 and then 4. I don't think.
Yeah, it seems that it is not reduced. It is just compared. Yeah.
I mean, if these two lines are output when it was run before, and these two lines are output when it's run this time, that's not likely to happen. but it doesn't sound like it's a bad thing, really. It's just interesting that they are equivalent in different order and evaluate.
Yeah.
So we're sorry to. Oh yeah, and you know, you always look at what they are. Right? Show print.
Okay, this was a good session, but you didn't record it. Do you want to start the recording now and we do the consensus part, or you want to keep going on this?
It's recording.
Yeah, it is recording.
Oh, it is? I'm not, I don't see it. Okay, yeah, I see it now. Okay, for me, the big news within the last week has been the Casper stand-up, which I think it's interesting that he hasn't posted yet. My suspicion on why he hasn't posted it is he doesn't want to, what's the word, upstage himself when he does the blog, the video, the
Arcast.
Arcast. And but I feel like we finally got what we needed with consensus, because someone stated, oh, it was who was it? The developer, Steve.
Kent.
Kent said to him, or said to someone, and I forgot who asked the question. Someone asked something about finality, and Kent's answer was, we don't have finality yet. And Greg came back and said, no, we have it now.
Oh,
Yeah,
okay.
yeah. And so for me, I feel like I don't have to worry about Casper anymore. I mean, there's going to be plenty of details to work out, but for me, that was a big stumbling block.
So he was saying that we have finality based on, so the
based on the error correcting code and the square root function.
Okay, so that is the error correcting code in square root was proving the constraints of a consensus model in a different way, and a way that's not as near as robust as Casper. And because those methods work in their simple form, they were deducing Casper, correct by construction Casper, because it's more mature, developed, and has more functionality. It's working the way they should, and I think he used it as a comparative model, using the square root, comparing it with Casper. One's working, they're both working in a sense. So, but I didn't realize that exercise with the square root and error correcting code helped to get determine that finality was achieved.
The way that I
Apparently.
understand it is that what that does is it relates to the spatial model of we have the differences of the different validators, whatever, and whether we look at those error codes or other formal way, there's a certain complexity that is local, causing local action, which is the space. It's in the center space based on the anti-de Sitter space that gives an emergent notion of time. That it's like once you exercise these things, you've progressed.
Okay.
And you have a common notion of time in a sphere.
Okay.
So
yeah, because
or ordering, and it's
Right.
not a formal ordering. It's not even a complete. It's not a complete ordering, but the
Partial
it gives you a notion of time, and
Notion
that
of
gives you
time.
finality, because you only have to look so far.
Okay, that's what I need to
Okay,
understand. Okay.
You don't have to. You can chop off all these other possible paths as
Okay.
being worth considering. Okay.
Gotcha.
And
But,
you're closer to
for
convention
me,
because you're not considering these crazy alternatives.
Okay.
to me, it was the big problem that was left to be solved, and I suspect that Greg's probably the only one that could solve that right now. But the thinking about this has made me start thinking about his derivative function, derivative of a process function that he's discovered or invented, or he and Mike, and I should include Mike on that because Greg always does when he talks about
Yeah.
the idea. But do you all understand that derivative function, or are you still fuzzy on it?
Oh, I got to take a minute and kind of think back to Monday. I understood it at the time. So bear with me here. It all comes back down to bisimulation, or when things are bisimilar, and this notion of bisimilar leads us to the ladle algorithm and this new world of behavioral types that we're moving into. So you have these notions of when things are bisimilar at a lesser level. You have what did he refer to it as? Trace. Well, bisimilarity gives you oh boy. Reason. Well, yeah, I'm getting it over my head real quick here. Well, I got to take a moment and kind of, he's
But
doing.
all the ideas you've said, I agree with, and I think you're on the right track and getting the hang of it.
Yeah.
But I'm starting to get an intuitive grasp of how this is going to work, and so just have we all had Cal 1 differential? I mean, we know what a derivative is in calculus. It's nothing more than the slope of the line tangent to the curve of the graph. So if we think about what does the derivative, so we've got this curve that, some squiggly curve on the plane, and say it's a region. Well, the derivative of that curve forms a boundary around your region. These straight lines are tangent to that curve all the way around it, and any one of those is a derivative of the curve at that point. They're a 0 point of the, I want to say they're like a 0 point, but they are, okay, but we're all comfortable with that. We're all comfortable with regions being bounded by straight line tangents to the curve. Okay, so now we start talking about, that's our model. That's what we're modeling things as. Now we start talking about the derivative of the process. Well, what Greg has done, he has seen parallels but between mathematical operations in his calculus that allows him to create this function that when he applies this function to a process, it gives him the derivative. And that derivative is a type. And that type is sort of like one of these straight lines that bounds our region of the graph. So we have our space of all possibilities that the grammar can produce. And then we have this limited region of possibilities that our types surround with all of their, they being the 0 points of these straight lines that bound our region of actual possibilities of our program. And so you take the derivative of it and you get the type. You get the boundary of the curve at that 0 point. Which would suggest that if you take the antiderivative of the process, you get the, I'm sorry, I said that wrong. If you take the derivative of the process, you get the behavior.
Yeah, I think it's, I think of it as, translating to the time domain, because what you're doing is instead, you have some system, and instead of the system, you're looking only at the changes. You're throwing away, in essence, the nature of the system.
Yeah, the derivative is the rate of change.
That's the derivative function, is the changes, right?
But it's also the behavior of that process.
Right. So it's what's happening to that. It's the state changes. So it's
so that implies
how the state of the system is changing.
Yeah. But it implies if the derivative gives us the behavior, then the antiderivative of the process will give us the type, doesn't it?
Yeah.
I mean, we don't have one yet, but there ought to be one.
That's interesting. And that's like the square root function, right? It's,
yeah. And what I'm wondering is all this discussion about linear types that's coming up, is that because of Greg's derivative function? I mean, is that being made necessary by his use of this derivative function?
Yeah.
But anyway, that may be a long shot. But do you see any value in that sort of model of what's going on with this derivative?
Yeah. But there's this different perspective. There's a lot of different perspectives.
Absolutely.
It isn't what's right and what's wrong. And we can look at it as taking a derivative, and we can also look at it as applying a distributed law, or a distribution. It's bisimilar in the sense we end up with relationships between the square root and all these other things because the process is so similar.
Well, yeah, I mean, bisimilarity says we can use the same rules of algebra on it. That's all bisimilarity means to me. We had something, we didn't quite know what the rules were with it. We found a bisimilarity to, exponents, derivatives, square roots. And we said, okay, we can use the rules of derivatives and square roots and.
Yeah. Well, I mean, there's a couple of things happening here. One is when we discover the bisimilarity, we're discovering the nature of something. We're seeing, how it's probably constructed. Okay, we're putting together, the process that makes that models it. And at the same time, we're looking at the effects of it in the environment, and looking at, I guess, the models we're building, and I forget what where I was going there. But.
Well, I thought of the words I was trying to think of earlier. So bisimilarity is that foundation, and because Thomas Law, you gave that great explanation of what bisimilarity was. 1 + 1 is bisimilar to 2. So with that, I was able to go in this Casper stand-up and kind of piece everything together. But so you have bisimilarity, and a lower level of that, you have trace equivalence. So if and there's a new word, erasure. So erasure is applying this coarseness to the bisimilarity. So if 1 + 1 is bisimilar to 2, so if you can, you have something on the left of the equation and something on the right of the equation, you use an erasure to give it this coarseness of where they were bisimilar, but now they're less than bisimilar. They have this trace equivalence. Okay, so now you have this two levels. Now above.
Sorry, but this example of 1 + 1 and equals to 2 is not really very completely correct, right? Because we can say that this is also structurally equivalent, right? Greg says that bisimulation implies something that is dynamic, right? So we want to compare different execution traces, right? Different execution paths that are the same.
Okay. Okay.
And Greg says that bisimulation is the best tool to do this kind of comparison.
And well, and so so you have bisimulation, trace equivalence, and then but above bisimulation is equational reasoning. So with equational reasoning, now you're getting into the world of mathematics, where you have so if you take this analogy in bisimulation, where if it looks like a duck, walks like a duck, talks like a duck, it's probably a duck. And that's for all alpha being a behavior, you can kind of reason that it's probably a duck. That's bisimulation. But now if you go into equational reasoning, now for all formulae, you can derive that something, and this is where you get into the derivatives. So where with all formula, if it looks like a duck, and I got somebody coming here, and it's just right in the middle of my explanation, but equational reasoning is what is the exciting piece. On that note, I'll be right back. Sorry, guys.
Yeah, we want to be able to compare two programs which are not exactly the same, but we can erase some dynamical behavior which is not important to us, and we can say they are the same in our environment, in our way of interpretation. So it's very similar how we are doing this in the grammar part, right? We have a grammar which is also which also has some ambiguities which we want to erase, right? like this 1 par 2 and 2 par 1. These are like the same structure, but on the grammar they are not the same, right? We need to write it in some order, but we want to say they mean the same thing. So we also want this kind of equalities on dynamical side. When we have these execution traces, we want to compare different execution traces to say, okay, they're really the same, right? Similarly, how we do this in grammar.
Yes.
We can have different sentences that explains two different the same action with different words, and we want to we want to say, okay, they are different in the structure, but they are expressing the same action, the same execution, and so they are bisimilar. So we definitely erase something, right? Because they are not the same, but we are erase something, and they are becoming the same. And I also think that Greg is searching for algorithmic way of algorithmic way of specification, because we can store in each step of derivative we can store the change, but this will occupy this will be like for performance very bad, and for storage, right? We cannot store everything. So I think Greg is searching for some kind of algorithmic way of specification where we can have this this like a compressed information. And he talks about this in this way. He says that this is like a compression, right? Mm. Because we have this algorithm to define like some kind of trace. So I'm just imagining that maybe we can build some kind of algorithm, some kind of program, right? Which can recognize 3D dimensions, right? So maybe we can have AI which works in this way. It recognizes with the algorithm, not the machine learning and lots of data, right?
It's interesting though how Roland already does that. I mean, what we're doing here, we have this. Oops, this is bisimilar to this. Okay, the words are different, but the thing is the same. Then what did I do wrong?
I wanted to add before I had to step away with my explanation earlier when I was talking about bisimilarity and equational reasoning. So he gave a real world example of that. Of now with ladle algorithm, you can take something that occurs, a process that happens in biology or in chemistry, and make a comparison to that same process to the world of finance. So you through these equational reasoning and the derivatives that Gary was talking about, you have these processes that are in totally different industries, but they're the same. And then you can map one out, something in biology to finance, and so those are the types of functionality and real world applications that he was looking for. So just wanted to add that.
Steve, you sound like you have a better understanding of this expression involving trace than I do. I always stumble when anybody uses trace in any discussion. What is your understanding of a program trace?
So a trace, you can think of a line. and you have 5 pencils on the desk, and you're drawing a line. And these pencils go from a very heavy pencil with a dark line to a very thin pencil with a very light line. So you're taking each pencil and you draw a line. So they go from the darkest to the very lightest. So as you go from the dark and heavy to the light and the light pencil, that light pencil, because it's still there, you can see it. It's still a line like all the others, but it's a trace. It's just it represents a line like the dark and heavy, but it's just very thin and narrow and light, and that's a trace. So you have to, I guess, think of the word trace in relative to something else, and that would be something that's, in this example, lines.
Tomislav, you use it more technically.
Yeah. I would think about, for example, if we have some summation, right? 1 plus 2 plus 3. What is the order of summing these numbers? Right? We can first sum 1 plus 2, then plus 3. But we can also have different order. We can say I will first 2 plus 3, then plus 1. So we had different traces, right, of this execution. We have some kind of tree. And we say, okay, this is one trace, and this is another trace.
And that I can relate that to what you're saying, Steve. Now having different marks there, showing up as different widths of line.
This is also related.
It's still a sum of this of 1 to n, but
it is also related how Greg was talking about this delimited continuations. How we also want to find this kind of trace and some kind of algorithmic way of specifying how continuations will be executed. I remember Greg was talking about this a few years ago.
Yeah,
that was interesting. So there's a relationship between a trace and limited continuation.
I see definitely a connection.
Okay.
Because and he was also talking about this algorithmic way of looking at delimited continuations.
Okay.
So this is like a part of the programs that you combine and say how continuations are executed. So.
Okay. Jim, I interrupted you earlier. You had your screen share on and you were showing something.
Oh, okay. I was just testing the concept here. Tomislav was talking about having the same thing with different names being equivalent, and I wanted to see what Roland would think about these two things here. One is for A, reads from X to A.
Quick question. Why are we using a double equal sign as opposed to a single equal sign?
That's the equivalence operator. I don't know what.
This is a structurally equivalent function.
Oh, structurally equivalent. Okay, that's
what
I mean.
This double equal sign is like a function with 2 arguments, but it's infix function, right? You have 1 argument on the left and 1 argument on the right. It will result.
Equal sign.
It's like a function.
Equal is not equal. Doesn't work.
Yeah, but it double equal, as Tomislav said, structurally equivalent. That's like alpha equivalence.
Right.
Yeah.
Not only alpha equivalence, but even more.
Well, that's so alpha equivalence is the trace element of structural equivalence, or alpha. So trying to use my math terminology.
Exactly. Yeah. Alpha equivalence is just a substitution of the names with the different names.
Yeah. So,
but you need structural equivalence, like a like more, something more to say that 1 plus 1 is equal to 2.
And that's the beauty. That's Greg is at, you know, these terms that we're using, the language to describe these different ideas and concepts. Greg's out lock hold on these things like solid, and they all, in this world of mathematics, they all have, they're very defined, and how they relate to each other is very important. So that's why, you know, being able to when you explain, you know, call something like alpha equivalence, you know, greater than that is structural equivalence, you know, having that appreciation for what they mean and how they compare is pretty important. So yeah, thanks for pointing that out.
Yeah, and Greg has a beautiful explanation of this. So yeah.
So we saw before that, you know, that this 1 plus 1 in parallel with 2 plus 2 is structurally equivalent to 2 in parallel with 4, or 4 in parallel. So the ordering and the value is the same. So they're structurally equivalent, right? And then we did this down here. We did this with a program where, you know, we have you know, different names for things, but they're the same. They're structurally equivalent.
Right.
And this bug that Isaac and I was find out, it is very much related to the structural equivalence and how the matching is working, because matching uses structural equivalence, right?
Right.
You need this structure equivalence rules to say what is the same, what match can match, right?
Right.
So, and Isaac is working on some maybe edge cases of this multiple bindings and how they are similar and how they are, you know, different, because you don't have like only one trace, you have multiple traces, so you need to calculate different paths. So
that was a helpful insight, that, you know, kind of the crux, you know, the core of that bug that came at Isaac found in K framework is, like you said, that it has to deal with structural equivalence. You know, there's something going on there in this, you know, realm of trace matching. So that was an insight to that bug that was very helpful. So thank you. Cool.
So structural equivalence is you know, structural equivalence depending on the trace, you know, defines the cases of behavior. How could, you know, they're equivalent in how they could behave.
yeah. Yeah, now we don't have a way to define this behavior for a process, right? We cannot check if some trace. We cannot write expression that will like type. We cannot write a type that will capture some dynamic behavior. We cannot say after receiving this message, this process will do this and then probably do this if receives this. So we cannot say this is now in type. And we need this kind of specification.
So we need to be able to look at behavior Okay, I'm wrestling with these issues.
So my understanding is that we need a ladle to integrate logic into rolling, and this logic, we want this logic to be something like model logic, which is very similar to temporal logic, and this is where I see connection to TLA, right? Because it has some similar constructions.
Okay.
This is what Greg was saying, that he wants to integrate these model logic operators inside rolling. And with these operators, this is diamond and box.
Okay, yeah,
Possibility and probability, I think.
Gotcha.
And then with these operators, we will be able to express this kind of specifications, protocols or programs, right? That we can say some kind of, maybe it's not correct to say some kind of sequence of actions, but some kind of a more complicated behavior that I'm not sure what model logics, what introduce what type of logic is possible with model logic. I'm not sure.
Modal logic is
I know that it has this temporal side, but
I know what you mean.
We were discussing this maybe a few months ago, and
yeah, I remember.
It's not easy to understand.
It kind of made sense to me. I think if you go to Wiki and start looking at it, it becomes pretty clear what the implications are and why we would want to use it for ladle. Yeah. But again, this area is so deep and so thick with theory that is hard to move around in. Okay.
Yeah, I remember that on these lectures, visualization was connecting different worlds. What can be reachable from one world to another? And Isaac is telling me that he found this very similar to reachability logic that is used in K-framework, and this matching logic. This matching logic with reachability logic, like it's very similar. It's defined this. I think maybe we can say traces in this finding these worlds, because I think that now we are now mostly thinking in terms of static things. Right? We are thinking about types that are also static. Like this gRPC, all these protobuf definitions, they are all static. Right? Nobody talks about these dynamic types, right? Types that can describe dynamic behavior. And this is, Greg mentioned this, I think, on last lecture, the session types that describes more information about types. They can describe some kind of interaction. So you need to send me 2 bytes, and I will respond with 1 string. So we have this more than just a static, like API. When you say I have these interfaces with these methods. So
it's behavioral.
Yeah, it's behavioral.
So you like to mix dynamic types with behavioral. I mean, you feel comfortable with kind of equating those two ideas?
Yeah.
But I don't mean dynamic types in the sense
Yeah. Dynamic types in a sense of this more advanced logical operators that are, you know, much richer than just logical.
Yeah.
Because now I think that we have logic in our languages, but it's very primitive. You know, this logic is not. It is not. I'm not talking about logic, Boolean logic inside the language. I mean logic on terms, how we combine terms. Like logic for like a normal language is just stuck one after the another. Like this is the logic, right? We cannot. We have some macros or something to work with terms, but this is not part of the language.
Have you looked at situation calculus?
I remember that I was looking at something, but yeah.
So,
Is that different from session?
Oh, I mentioned session types.
Session types is related. Situation calculus defines a situation in terms of fluence, which are time-varying attributes, or, you know, parametric in time. And it's interesting that one of the developers of situation calculus was a butterfly collector, and Darryl has his collection. He's connected to this guy, and so I just happened to look up and discovered situation calculus, which situations into first order gives first order logic for a situation, which seems very much related to what you're just talking about.
Yeah.
You said Daryl. Is it as in our Daryl?
Daryl Nordorf. It's funny you should mention that, because on the last R song, he was talking about this butterfly collection. He said he was going to have to step away because someone was coming to pick up. He was holding a butterfly collection for someone who's moving, and everyone was all interested in this butterfly collection. So to understand that the guy who it belongs to is the creator of situational calculi is kind of interesting. So I'll have to bring that up today if I join the R song meeting.
Does Daryl have is Daryl into mathematics?
Not really.
Oh, okay. I just wondered. I thought maybe he was a student of this guy or something.
No, apparently they're acquaintances in some regard. Yeah.
All right.
Yeah, I forget exactly how they're connected, but I mean, it was a pretty strong connection, whatever it was.
Okay. It could have been family or something.
Interesting.
Yeah, this could be somehow related to session types. I'm wondering what Greg was mentioning about negation and how negation is something different in different logics. But I didn't remember what exactly he was talking about.
Well,
but he was saying that this negation is something that needs some kind of constraint, so that this summation preserves power. So, yeah. I think that all of this is like a way to constrain these traces so that, you know, he can calculate, he can compare different states very easily, not executing everything from the beginning. He can say, okay, you have this trace, you have this state of your virtual machine, and I will find the trace very easily and find out, is your state really valid state, or you just or you're cheating somewhere, right? I see this very much related to this zero knowledge proofs and they are doing the same thing, but I'm not sure that. I think that Greg was thinking more low level in that sense, so that all of this stuff will be inside the protocol and not something that need to add later and calculate.
Let me ask another question about trace. We talk about trace of a program. In the Erlang world, would we be better off about? Would we be better talking about the trace of a process?
Yeah, or trace of execution, trace of reductions. He was talking about this.
The reduction is all the little pencil marks it went through to get to the final reduction, right?
Yeah. All of these erasures, right? Because a reduction is really an erasure in one way. We cannot go back.
Now I'm getting. Yeah.
Sorry.
Now I'm getting the idea of erasures as well. Thank you. That helps.
If I'm almost there, I'm hearing all these words that I know what they mean individually, but collectively I didn't get the idea. Say it one more time and maybe
So we need to trace all of the reductions that happened until this point. So we can have send and receive on the same channel, and we will just combine it. They will disappear, and we will have another state which is continuation of this receive. But we cannot go back. We cannot say, oh, we know these two, send and receive, this pair. We know who they are, and we lost this information. So this is erasure.
Oh, that's the erasure going as you go through the reductions. Okay.
Yes.
And that was helpful.
Erasure, the real erasure. Greg says they should not be mixed up with this erasure, something like erasure in grammar. When you say 1 par 2 is equals to 2 par 1, because this is not erasure. This is just saying this is structurally equivalence. We are not erasing anything because we are not using this information later.
Right. Okay.
So this is not erasure. And when we do a reduction, we really changing the thing, and we depend on this change, right? The program executes, but we are losing this information. We are erasing this.
Okay. Man,
so I'm imagining that he have a way to label all of these reductions, in a very smart way to say I have a trace, which is mathematically and everything like provable and nice.
Mm-hmm.
And that leads us to your thought about label transition systems.
Yeah, and I think that the Greg is saying that label transition system it's more it's not that it's difficult to work with. I think he was saying something like that.
Yeah.
So I'm not sure if he said that Abramsky had this another idea how to make this. Maybe this is the difference. Labeling reductions or labeling transitions. But I'm not sure what is the difference. So yeah.
Okay.
But they used operational semantics to somehow label these reductions, in contrast to the notational way of defining, which I'm not sure also how it's in details. Yeah, Hoare logic is more denotational, and it's very difficult to work with. You need to
Which logic? I'm sorry.
Hoare logic. I'm not sure I'm not saying this correctly. Hoare.
Spell it.
Oh, this is even difficult. Tony Hoare. So here's the link.
Tony Hoare?
Oh yeah, we say Hoare.
Oh, Hoare. Oh,
yeah.
Sorry.
But yeah, now I know who you're talking about. I'm sorry.
Okay.
Hoare. Yeah.
Okay. Now I know.
Yeah.
Yeah. I've been trying to find the language he developed back in the early 70s, ACL, a communication language, which was very cool, but it was not Turing complete. And all traces of it seem to be gone. I guess I have to go to a real library and get the communications of the ACM out to find it.
Yeah.
But I thought it was really interesting to sort of the first attempt at a process language process.
Is this related to his triple with? I was listening to the interview and he was talking about this triple of
Right.
state and.
Now, ACL was just a very simple language, where the only thing you had was channels, and well, I guess processes. It was really communicating sequential processes.
Oh, this is that was before.
Well, they weren't sequential processes. What am I talking about? But in any case, it was a very interesting language, and I've always wanted to. I felt that the limitations are important, in that you don't want the system to get away from you. In essence, you want to be in control. You want to control it. You don't want it to control you. So the limitations of ACL seem very appealing in terms of building a system you could trust to not turn against you.
But you are saying it was not powerful enough, right? So
I don't know. He was criticized for it, and I think he lost a lot of credibility. I think people like Greg sort of poo-poo Tony because he's gotten sort of a bad rap, and that started with this. He came out with this thing that wasn't Turing complete, and he never said it was. I don't know what the big deal was, but and his laws of computer programming, I think, are really cool. I mean, nobody knows what those are anymore.
the laws.
Tony, what's his laws? I can't believe I should know that. I'm one of his old groupies from the 70s.
I think Isaac would know to say something about Hoare logic.
Jim, the laboratory he worked at was called Atlas Computer Labs, and the acronym for that was ACL. You're not talking about Algol, are you?
No.
Okay.
communication language.
All right. You're right.
As I
Nobody
say,
talks about it.
It got lost. Okay. Damn it. I guess the best thing to do is probably get a just watch a video of it. I should be able to say what they are, but I'm not even going to try. This was there's no date on here. 1967. Interesting.
I found one. Hoare law of large problems. Instead, every large problem is a small problem struggling to get out.
Okay, well, yeah, I think it's worthwhile checking out some of this stuff. Communicating sequential processes was a big deal.
Yeah. And that was somehow popular a few years ago. I remember in Clojure this communicating sequential programs. There was few libraries, and I was playing with some libraries, and but I felt like something is missing, right? So exactly what Craig was.
My last foray in exotic languages was Clojure, just before I found Archain, and that was I felt that was a good transition. I'd been introduced to enough of these concepts of concurrent programming and Clojure that I don't know how I hung on, but I did. Because there's been a long time of hearing words like Steve's talking about, hearing words that you kind of recognize, but you don't quite know how to put them together into meaningful expressions yet. But Steve, you're moving much faster than I ever did.
Well, thanks for the compliment, Gary. This is fun. That's the beauty of these sessions is, getting together and chatting about this and, having all the light bulbs go off and, connecting the dots. So, this is great.
I can probably, learn more in one or two of these sessions than I can learn in a lot of books, just reading books.
Yeah, it has so much more meaning. It's the social aspect and interacting. It's when you hear something, you learn it. I mean, that level of being ingrained in one's mind is so much deeper than if you were to read it, on a white paper or somewhere. It just has more roots to it.
Yeah. I remember I was watching some lecture from Dana Scott. He was mentioning this guy. Greg was mentioning this guy related to this to this. I will remember for lambda calculus to and lambda calculus and continuous functions, I think. And in this lecture, yeah, I just wanted to mention with the context. And you know, this guy is a mathematician, and he was explaining. He's now retired, I think. You know, and he was just explaining how some of the formulas, and he got the question from the audience, right? How we think about the syntax, you know, where the brackets, and he was just, oh, mathematicians don't think about it. They just say what they mean, you know, and these formulas are just like
Yeah.
they're not important. They know what they mean, so you know, and everybody laughs, you know.
Yeah.
That's interesting.
You know, we programmers are very we are very careful about the syntax, you know, because we are constantly you know how to say constrained by the compilers, right? For each bracket you're punished, you know. We're very careful where the parentheses, and you know,
Yeah.
what comes first and what is applied to what, you know. It's not just, you know, we know what they mean. So
but you know, all these morning sessions have given me appreciation for, you know, I hear about Samson and Bransky and this his paper, the computational integration of linear logic. You know, after hearing a number of that, I finally pulled it up the other day and started reading through the first page. You know, it's about 47 pages, but you know, now I'm building up to starting to pull up these white papers, and now you know, it's this. It's opening up a world of mathematics for me. You know, I took a lot of math in high school and some in college, but you know, I never went on, you know, beyond that. But you know, this is all these discussions are helpful in piecing this. You know, it's kind of like the history of mathematics, because you know, Greg quotes, you know, all the different papers, and all these mathematicians, they build on each other's work to get us kind of where they are on here. So it's kind of this history of what's going on. So you know, now I'm having a greater appreciation for what's happened in the past 100 years in mathematics, and now I'm curious to find out, you know, how did we get here with you know, Rolang and computational calculus? Well, hey, go back and read the papers and all the people who wrote them to make it all happen. So yeah, it's I feel like I'm kind of on a journey now. It's you know, and it's, you know, years in the making. And so, but you know, when I hear all these when I get an idea, you know, just like structural equivalence, you know, it's after watching you know, Greg's presentations on computational calculi. There's 12 of them, and I'm up to number 7 now. But you know, he introduced, you know, in series 2 or 3 alpha equivalence, and from that I understood structural equivalence. And you know, to see it, you know, Jim's code in a way, you know, it's like, oh, that double equal sign, that's not equivalence, it's structural equivalence. I'm like, you know, it's just like, wow, you know, everything just kind of comes together at that moment, you know. And so now I'll be, you know, when I get into writing code, some Rolang, you know, in describing it, you know, be sure just, you know, it's, you know, someone's looking on trying to figure this out as well. But, you know, to say, hey, you know, this is structural equivalence. And then, you know, just passing the torch to someone else to try to figure all this stuff out. So, You know, this is the more I get into it, and I've been into it. You know, it'll be a year in September, and next month is when I signed up for my became uh, uh, a co-op member. And the more I get into it, the more I want to go deeper. And I feel like there's just so much more to figure out. And you know, I asked myself, you know, there's over, if you go to Coin Market Cap, you know, there's 2,000 platforms on there, and there's probably thousands more that aren't on there. And it's like, where do you want to be? Where do you want to devote your time? And you know, I just kind of found myself here in this world of our chain. And you know, and because I'm in block spaces, I have exposure to some of these other platforms like Cardano and Corda, but this isn't what's going on here in the art chain world is completely different animal than what's going on in these other worlds. And I'm like, you know, I'd be interested in looking at these other worlds, but it's nothing like what we got going on here. And just the depth of what is going on. And I mean, every time you know, next week, I'm like, I'm getting deeper and deeper in this, because there's like this universe is just open up. I'm like, I can't believe what's all out there. I mean, I've got years worth of, if I wanted to understand this stuff to the level of, you know, to any of you guys, you know, I've got, you know, 2 years, 3 years, 4 years. And, you know, but this, like Greg said, blockchain's not going away. I mean, this stuff is here to stay. And, you know, we're just at the very beginnings. And as this stuff all gets, developed and becomes part of, you know, this world we're creating, I'm like, hey, I've got my hand in it, you know. So this is exciting stuff. Yeah.
It is.
I like your explanation of how this is built from all the other stuff before, and you know, it's like in many different platforms. It's like many different traces, right? And you're choosing
exactly.
And you're saying that this rolling trace is the most like interesting
and I get that from Galileo. You know, they asked Galileo, how did you, you know, what, you know, it was his visions of the universe. And it's like, you know, how did you come up with such incredible, you know, ideas? He's like, well, I got it from standing on shoulders of giants. Because before Galileo was Kepler, and before Kepler was somebody else. And, you know, and it's like, you know, that's this world of science and math. You know, everyone's standing on the shoulders of the person before, and just kind of sitting back and appreciating that of how, you know, so all this stuff that we're learning now is going back to, you know, built on stuff going back to Galileo and Kepler, and before that, you know, it's all been building over time, and it's going to keep on going. So now, hey, end of the year, we're going to start working on the ladle algorithm and behavioral types. So I mean, we're standing on each other's shoulders.
Yeah.
And what 2020 is going to present. You know, I mentioned earlier about this idea of, you know, you've got biology and and reactions and relationships that go on that can be carried over to the world of finance. And, you know, Greg gets excited when he talks about that. Is like, now you'll be able to do things that were never conceived of before. And just to wrap my head around that, I'm like, wow, that's, you know, behavioral types and ladle algorithms, all that. This stuff is coming, and you know, it's I'm just like, this is amazing stuff. Yeah. Well, I mean, I can go on, but this is cool.
Not 10:30.
Well, there's a our song session at 11 or in 5 minutes if anyone's interested.
I've been attending those recently, and I feel I would like to go to that. They've been pretty good.
It's a different, here we're getting down into the mathematics and, the white papers and stuff like that. And our song is a completely different, a different type of session. They're talking about more of the social aspects of change and how music influences and stuff like that. And it's a different type of discussion. Going off in a different direction. So it's always entertaining to sit in on those.
Yeah, I like discussion. Sorry.
Go ahead, Tom Sloan.
I just want to say that I like this discussion with Eric, this guy from
yes.
That was exactly what I was going to say.
So,
yeah, he's added a lot to the discussions in the RSong group.
Yep. He has, and that article that he wrote in Medium helped me get my head around these ideas that he's been presenting for the past few weeks. So now when we go into the blockchain art sessions, I feel like I have a little bit of a more firm footing on what he's trying to express. So yeah.
Yeah, I'm trying to follow. So. Yeah.
Yeah, and now the thing is, the ultimate thing will be taking his ideas of this distributed object framework and bringing it into our discussion here of how do you build that? I mean, how do you what's the mathematics behind that, and how do you code it up? And that'll be an interesting topic for us in the future when we get into RCAT. It's like, okay, now we're tasked with trying to build a distributed object. And what's it gonna look? It's gonna walk like a duck, quack like a duck. It's gonna have alpha equivalence, structural equivalence. And what what papers can we look at to kind of get a better understanding of what needs to be built. So yeah, it's all, everything kind of starts in the idea world and works its way to, and Eric's very motivated. It's like, hey, he's been in the idea world too long. He wants to build this thing. He wants to make where the rubber hits the road, and he wants to see this thing actually pop up out of the ground. So I'm like, wow, that's, yeah. So and hey, if I can pay a little piece of that to help it move from this ideal world into the real world where you can actually get your hands on it, touch it, and make it do something, I'm gonna kind of move it along. So yeah, exciting. So
yeah, I have my examples now working with deploys. So yeah, I managed to sign deploys offline directly in the browser, and with this library, you can generate all the code, and you can sign the deploy. So I have everything ready for a wallet. So
cool.
Yeah, I wanted to show you my what I was saying about the static page. So here is the repository. I need to put this in Discord. Oops, my Zoom is very slow. So this is a repository with the samples for Node.js and for browser. And you also have a link where you can click and open a sample page which communicates with Arnold.
Okay.
And you will see just this output from few commands. like last block or get blocks and visual output and one deploy.
Interesting.
This is done inside the browser to the testnet because I publish a proxy to all the validators for testnet, for devnet, and for sandbox. So I will keep this running, and with this example, it's very easy to start making requests.
Okay.
Nice.
So maybe now we have something for Eric to to play with and to build something.
Boy,
So,
it looks like something for me to play with.
yeah, if you fork the repository, you can try everything on your PC.
Okay.
And you can definitely tell me if something is broken or.
Yeah, will do. I'll definitely do that. If I'm up to setting this up, it looks fairly straightforward.
Yeah, you only need Node.js
Okay.
because
I
this
got
is JavaScript. You need Node. If you have Node.js, then just follow the instructions and yeah.
Okay.
It's very simple. Just a few commands and.
I'll let you know how it goes.
Great, thanks.
I have to figure what's next. We in the work study last night. We tested the liquid democracy and it worked. We confirmed the bug that NetZipper found. When we deploy the ballot program, we get an invalid block. I mean, we can't propose it; it gives an error.
Yeah.
But we can evaluate it written in Roland, and it works. It works as advertised in many cases. I don't know what the next step is. I guess we want to try to run it on Sandbox and on testnet just for the bragging rights.
Yeah.
I was saying we did that.
Yeah, and if you connect directly with gRPC, it works much faster because you don't need to wait Arnold to start up to this other instance to just make a gRPC call. Yeah, it's much faster when you communicate directly. So yeah.
So,
yeah, when you open this test page, you see how fast. Sorry.
Yeah. Okay. Yeah. So now we'll look into hooking robot up to it. Right?
Yeah. I mean, robot is with Node.js, right?
Yeah.
Okay. I'm thinking on some lightweight communication with Discord and something that now we can plug something and simplify maybe the code.
Well, the existing code, calls the Archain API. Right.
Oh, you're using Archain API. Okay.
No, we're not using it. We have code that's broken that uses.
Oh, I see. Oh, I see. Okay, then maybe we can plug it very easily. Yeah.
So.
Yeah, you have all the code on GitHub, right? This is the latest version. And if I see the code,
That's not the latest version now.
Okay.
But I should push it.
I mean, maybe it would be nice that the code is not on the server, but on the GitHub. So you can develop all locally, and then you publish because that will allow more that will allow development in a team, right? Because now it's very difficult when you know, if you change something directly on the server.
Well, yeah. I mean, I guess it's you know, having we have to create test bots and things. I mean, as it stands now, we you know, we just share the ArcChain password for robot.
Yeah, but it's
And,
in this way it's difficult to work when multiple people are.
Yeah, you know, we get to test here, right? You know, if we build another test and we have to create another test robot.
Yeah, but you know, you test locally, and when you finish, you just, you know, push on the server. You know, we can have a branch which will automatically push this version on the server. So we can develop everything locally or different branches, and then just, you know, when you want to publish a new version, you just push, or for example, on the master branch. So the repository will be the latest version which is running, and we can talk about this, you know, more easily. And you can develop everything locally, so you don't have to connect to the server.
Just we have to create, you know, create a separate bot for each channel where we're going to test. Okay.
But when you develop, I'm saying that when you're developing, you don't have to be directly running on the server. You can run it on your local PC. We can.
Well, you're going to be running a bot on Discord, right? You have to run a bot on Discord, so you have to have
Yeah.
You have to create a bot to run with.
Yeah, but it could be local, because you know, it's much easier to make changes when you're working locally than, you know, on the server. You can use your own editor and everything. So it's,
Yeah, you just need a bot. You just need a bot. You just need a bot and a Discord server to test on. You can't have if you're running multiple bots, it's going to do things 10 times. You can't run multiple bots with the same bot.
yeah, I mean, we can have only one that is really published, but when you designing things, you can do everything locally without Discord, right? Because we can abstract Discord, right, and you can work directly on your local machine.
Yeah, I'd have to run an R node, and you know, it would be out of sync with the database, so it would have to be in a different server than the Colab.
Yeah, definitely. Yeah, it would be the best that you can use your own local R node.
Yeah.
So you can develop everything locally. And
Yeah, well, you know, this is supposed to be a collaborative real-time development. In order to do that reasonably, I think it has to be a shared instance of a database and macro.
I agree, but I just thinking, how can we write code in more style that you know, other developers are used to, you know, because we are now doing this. We have this repository which is automatically published. So
The way I'm sensing this, it's the workflow. So Jim, Thomas
Yeah.
Lob wants to build on what you've been working on robot. So he wants to get a hold of that so he can start his development. But he in order to get easier access, we're trying to figure that out. So the way I'm understanding it is GitHub is, you know, is that central repository.
Yeah.
And but I know you have your concerns, and I'm not up to the level to understand what they are. But I think the goal is to figure out how can we make allow Thomas Lob and others to start coding and developing. You know, he wants to take what robot and start working on it, add it with
Right.
his browser. How do we get
the
that?
README file gives you instructions for creating your own bot. You know, I don't know. I mean, everything's there in the repository.
Yeah, it's a lot easier if you run your own bot. But you know, Jim makes some good points about uh, uh, having some sort of central development server.
Yeah, some places you have to be where the people are in order to test.
Well,
So
you know, you can run a Discord server. You can run your own Discord server, and you won't have any problems. I mean, if you're running different functions, it doesn't matter what your bot does. I don't understand what you were concerned about it reproducing 20 times.
I guess, yeah. I mean, I agree with Thomas Love that that people should develop with their own bots, their own things. I'm not quite sure what his point was here. I mean, I was going to update the repository, so I'm going to do a git commit.
so what I'm saying, it's like you develop you changing the code on the repository, not directly on the server. So the server will just pull the latest version.
Well, when we're testing, like each time we hit a bug, last night I would fix the bug, and then we would continue testing. I have to be where the people are. This is if I'm running on my own machine, there's no people there. I don't have, we can't test the community stuff. And, it's a lot, for most people, setting up their own environment may not be that easy. I don't know. But they could easily define macros. And
well, I see it eventually. Everybody's going to have their own bot. So I'm not really worried about people learning how to develop it on their own machine.
Are they everyone connected to the server, or they're just looking on the screen? I'm not sure how you do this development. Jim, you said when multiple people are
well, I mean, we don't have. I mean, I'm the only one that's doing it now. Myself, David, Valentine, and other people that were modifying it just didn't step on each other's toes, I guess. If you want to develop something, you can call it ballot 1, ballot 2, ballot 3, so you don't step on the main ballot. But if you're fixing, if you're fixing it's easiest just to make the changes in ballot, and then
I'm just thinking
you can always revert back.
I'm just thinking that for new people, these rules are very difficult to catch up. So in this style, it's very difficult to someone to engage. So I'm just thinking that if we can have simpler rules, then it's much easier. Because most of developers like some kind of template that they can just start from somewhere. This is why I'm building these libraries, that you can easily start, that you can just download the repository and start. And in this way, I'm thinking about the robot, right? You just have some starting point that you download. You can choose to use testnet or whatever, and and then you can when you find out more, you can engage in some kind of more complicated programming in groups.
Password for. Okay, so Jim Scarver's up to date. Oh, is Rao's on the phone? Where's Rao? Read the docs. The R-Chain NutZipper's documentation link is what Rouse wants.
Oh, he wants the readme.io, rchain.readme.io, the website.
Is that what it is, R-Chain?
Well, here, let me go to my screen and verify. I think he wants the community repository.
R-Chain community, readme.io.
Yeah, R-Chain community. Yeah, R-Chain dash, I believe. R-Chain dash.
I got it.
Yeah, I'll put it in the chat.
Yeah, I sent it to Rao.
Okay.
So, sharing my screen still.
So Tomislav, what Jim just updated on his GitHub, is that helpful to you to be able to interact with a robot?
Well, I'm just looking how to replace maybe this. If this is done, calling the R node to deploy, then directly using the JavaScript, it will be much faster. But I'm not sure. This server.js file is a file that is running and accepting Discord messages, right?
Yeah. So yeah, down in the README down below are the instructions for creating a bot.
But you're using R-Chain API.
It's not. I mean, if you type Roland : it uses it, but it doesn't work.
I'm looking at the deploy. Are you using deploy or you're just using eval?
There's a deploy command.
But you're saying this is not done.
The deploy command, it may be useless the way it is. It deploys the last thing you evaluated. And then the propose just proposes a block. But right now we're just using a DAO, which it runs R node. But you know, it's clearly wrong. No, it doesn't deploy anything. I mean, except when you type the deploy command. And you know, I was going to see how that, see what that does. I don't understand. You know, it's not clear what that'll do. I mean, if I deploy, like I deployed, we created a poll yesterday, and we all voted on the poll. And then I did a tally of the results. Okay, and then I deployed the tally of the results. So I don't know how this all is going to look from another node. What's going to happen? Am I going to be able to vote on it? You know, where do I need to do deploys? You know, to keep the state across all the systems. I need to deploy people's lockers and their mailboxes.
So if you work with the blockchain, you need to register everything globally, right?
Yeah, but we don't want to work with I mean, we want, a lot of the stuff we're doing is just user interface. We don't really need to put it on the blockchain.
Yeah, but we have these two different virtual machines which are not connected. So if you publish something on one machine,
Yeah, so when you're doing an eval,
yeah, and val is a different tuple space. So this
So-
is not connected to blockchain. It's completely separate tuple space. It's the same. I think it's right. It's almost. I think it's the same, right? And but it's separated from the tuple space, which is replicated between all the validators in the network. So
yeah,
in a sense,
I have to do some tests. When I do a deploy,
this is what I was thinking. This connection between these two virtual machines, between these two tuple spaces, because you're right. You can have some code in your standalone tuple space, but you want to pull this code and publish on the blockchain, right? Why not? But you need to store it now. You need to store it as a file and just transfer to.
it would be very interesting to see what errors you get. I mean, if you just deploy selectively stuff.
How do you mean?
Well, okay. Well, when you register something, okay, when you register a name, you say that the names you register in eval are different from the ones that you register and deploy.
Yeah, I'm wondering what does it mean to register in val? It's still the registry, right? But it's definitely not connected to blockchain. It's just, it is not replicated. I'm not sure how registry works in this tuple space. I never tried it.
So basically, the current voting algorithm isn't on the blockchain. It's written in Roland, but it's not on the blockchain. And what you're telling me is I'm not going to be able to selectively put what I want on the blockchain. So it can't be fixed really the way it is. But
the goal is that we vote with deploy, right? I create a deploy, and this is my vote, right? That's the goal.
The goal is to deploy, yeah.
So I will try and make something similar as an example from the browser that you can just select the contract and give your vote, right?
Why don't you just fix the server.js to use your code?
Yeah. Definitely, I need to go to the code and see how can I plug it in, and yeah. But I want to make some example that that is easily usable, and that you can easily create your own bot.
Tomislav, can you show an example of your code running?
Yeah, sure. So,
sorry, Steve, I didn't mean to interrupt.
That's fine. I was just say that's if Tomislav gets this working, it'd be exciting to see.
So this is the project that I was talking about. And working example is this link here. When I open this link,
Oh, okay.
this is the communication with test node.
Nice.
And the last one is the deploy. This is the signed deploy, when it has the code, timestamp, limit of flow, deployer, public key, signature, signature of these things, term, timestamp. I'm not sure if flow limit is inside. And it specifies what signature algorithm is used to signing, and that's it. This is this can be I will use to store offline deploys. So you'll be able to use the wallet on your offline machine, store this as a JSON, and go to online machine, load this JSON, and send to output. So you don't have to expose private key on online machine.
Yeah, this is nice.
With this example library, I created these scripts in package.json, which is a command that you can run with npm run. I can say build web, and this will use this parcel library to compile JavaScript in version that can run in the browser. And the resulting folder is this folder. And I will show how can you build this yourself, right? When you follow the instructions and create and call this build web, you will have the whole page compiled in this folder. And this is a little slower when Zoom is working.
It's because you're running Zoom, I'll bet.
Yeah. Zoom eats all my memory, so. I was already wondering if I need to restart. So the compilation is really gives these three files: index HTML and JavaScript that is referenced. So if I double click on this file, it's totally offline, right? And it's doing the same thing. It's doing the deploy and everything. And so this is how can you run it. And the source code is separated for Node.js and for web. And if you look at the code, it's very similar. That's the whole point, right?
Yeah.
This is the whole code.
Mm.
Nice.
Each of these lines is one request to our node. So
there's still a proxy, right?
Yeah. I'm running proxy for testnet, for devnet, and for sandbox. It's available for these addresses. I will publish all the addresses so you know what can you use. So if you want, now you can connect to testnet without any running your proxy, because I'm running proxy for all of these validators.
Sweet.
I think we need this kind. I want to show that this would be very useful for Arching to run these proxies. Just as a convenience, right? So we can easily depend on HTTP. But yeah, we can also run these proxies ourselves, right? But we need some kind of trust.
We need some kind of what?
Trust, because these proxies are like third party to Archer.
Okay.
Right? So it will be much nicer if Archer says, we will run proxy, and you can be sure that we are not doing something crazy.
So, but you can keep the private key in the browser.
Well, for a wallet, I will not keep a private key. I will just I will develop something similar to my Ether wallet. You will provide your secret information, and I will only store it in the memory. So if you refresh the page, you need to start over, right?
Right. But we can. I mean, we can do that in the browser code now, right? We don't need, right? I mean, we can. I mean, we can have a static page that reads that.
Yeah, I mean, this library works in the browser. It is not like Archer API. Archer API only works with Node.js.
Now, I guess I'm still a little confused as the architecture here, because we have the Node.js server, and then we have the.
There is no Node.js server. It is only proxy. There is no Node.js server. For example, this static page is published on this static page. Is published on the GitHub. So when you look at the GitHub pages branch, here is the page.
And where is the private key?
There is no private key. I'm just I'm deploying and I'm generating the new private key each time here. Sorry, I didn't understand your question. I'm just generating for each, for each request, I'm generating new key.
Okay, but if you had this page on your local machine and ran this page on your local machine, you can put your private key here and keep it on your machine, right?
Yeah. But yeah, I will not store it anywhere inside the browser. If when you refresh,
you throw it away when the session's done, or
yeah, it's just in the memory. So yeah, when the page is, the window is not destroyed.
Okay.
Yeah, I would. But if you use MetaMask or something, it saves it in the browser, in the browser memory. Right.
Yeah. I don't know.
You could save it if you want, if your application wanted to save it
with a password. With the password, right? Did I ask you for a password to encrypt, right? Yeah. Okay. Yeah. It can be done, but I'm not sure if.
Yeah.
We can encrypt the private key and then store it, but it's definitely possible.
Yeah, like you said, with the password.
Yeah. I will create some helper functions to convert a private and public key from a hex string or this kind of stuff, so that you can easily work with keys. And so and then the next thing is now I will create some kind of testing playground that you can enter your contract and publish directly on the on the test net or any other net directly from the browser without server, without anything else. So yeah.
That's
we can have
right.
you just clone, you just fork the repository, and you have everything in place. In the settings, you have this option to publish your page, and you can say this is the branch that I have in my static site, and this page will be automatically published on this URL that you will see here. So you have for free, you have options to publish your page on GitHub directly from the repository. So you just create another commit, and you will have a new version. And this is why this is very convenient. You don't need your own server. You don't need anything. You just create a repository, and you can have your own wallet in your own repository. And
wow.
I'm thinking we can have different themes, like different designs. So you can choose different design for your wallet, and you can have your own application, right? Because this site can be the same site that I showed you before, that you can install on your phone or on your desktop, right? Steve, you know what I'm talking about.
Yeah.
So you can have your own, like your own server with your own application. It's just
neat.
for you.
Okay.
So I think this is the next step, that we all can build our applications ourselves, right? We don't need like a special programmers to create application for us, and it will connect to a blockchain.
Wow. Neat.
So yeah,
I'm planning to add some. Yep. Sorry.
So I guess a simple thing to do is just put up a page with the text box where you put in your role length.
Your role length here. Yep. And I will put the drop down for all of the validators, so you can choose which validator you want to send your deploy. Because I noticed that on testnet, some of the validators are they're responding slowly or with an error. So because I was thinking that I will put all the validators from one network in one cluster, with some kind of strategy to distribute the load. But they're not the same. So I ended up to this configuration that you can manually choose which validator you want. So this number 8 is working normally when I was testing. So yeah, and I will put some more documentation that is more easily understandable. And when we can have this information from a blocks directly in the browser, now we can think about some kind of a block explorer that we can browse the graph of all the blocks.
Right. Okay. Ooh. So that'd be creating the DAG graph that, like NutZipper, what he puts together.
Yeah. This is the output from this graph. Where it is.
Okay.
Here.
Yeah. That. Okay.
This is the output, and yeah, in the console you can see maybe even better. You can inspect some of the objects. And I refresh. you can inspect objects because, you know, this is like developer toolbar, so you have more control.
Okay.
And I can copy paste this graph, this output from the Arnold. You know, you made a request, you get this output. This is like a string, and I can fill it in this program, and I can see the graph.
Oh yeah.
Oh, wow.
I love, yeah, the visual aspect of all this is neat. It gives you an insight into what's going on with consensus.
Yeah, and then when we have this information, we can build other tools or other graphs, or, you know, because they are just connected hashes, and we can just, you know, use some tool to display it. And I would like to build something more interactive, that you can, you know, open like this graph like a tree and go deeper. And
Wow, that would be neat. Yeah, I mean, and then you know that's taking a peek under the hood what's going on in the world of consensus, and then with that visual tool, you can it would be helpful to explain to someone else, you know, what is consensus, how does it work, and you know now they've got something that they can relate to and see to kind of understand what is, and so that, yeah, that's good stuff.
yeah, exactly. Yeah, we can think about some useful applications that we can use to exactly that purpose.
Mm-hmm. And this, it's the consensus. I mean, that's the big differentiator. You know, so blockchain is different from everything else that's out there, and then uh, uh, proof of stake is different from proof of work. And you know, having a visual of what's going on. This, I mean, the proof of stake. This is what's going to change the game. And being able to see a graphical representation of it, you know, that's the visual presentation to someone who's not in our world. Say, hey, this is the thing that's making this happen, and what's going to make everything change. So I mean, that's, yeah. Well, yeah, I'm excited about all the plans and the work that you and that you have, and how you kind of laid it out for, you know, how you want to progress. So I'm kind of like the guy sitting in the audience watching the movie play out, and I'm watching the plot go along, and I'm just like cued into to the storyline. So okay.
Yeah, and I'm thinking, how can we all participate in the movie?
In the movie, exactly. Yeah. You're the on the production team, creating the production. Now we're the actors. Hopefully, we'll be the actors in the play. And you're creating the scene for all the characters to participate in. So yeah, Gary, you get to be the director of the movie. You're
Okay.
You go over here, you go over there, and everyone's got a role.
This is.
I will try it for next week. I will try to do bonding directly in the browser. Right? You choose your validator, and this is like your machine, and you don't execute a command on your local machine with your terminal. Right? You connect with the browser and just, you know, deploy your bonding contract from the browser, right? And, you know, your communication with the validator is from the browser.
Very nice.
Yep, absolutely.
That's awesome. Awesome. So let's see. It's 12:15. We pretty much missed the blockchain music.
Yeah.
It's supposed to be at the Digital Life Collective meeting.
Okay. Well, I probably need to run too, but Tomislav, thanks for this, and everybody, thank you. I will attempt to install this and try to get it running, and I'll let you know how it goes. But anyway, I need to take off. Thanks, everybody.
Yep. See you, Gary.
Me too.
Okay.
Guys.
See you.
All right. See everybody.
Bye-bye.
Have a great day.
Nice conversation. Bye.
Yes. Enjoyed it.